So, first thing is we need a grapher, right? So you use your grapher, or you can use these points to guide you. They're locking this in at y equals to 1. So let's go ahead and graph that guy. Let's see, let's just make it, yeah, 1, 2, 3. Okay. Let's put 1 here and 2 there. So I know x equals to 2 is the revolution line right here. This is where I'm revolving, right?
Yes.
So that says y equals 1 is one section. Y equals 1 is a horizontal line. X equals 1 is a vertical line. Right? And then we need to look at where the heck is x cubed. So I'm locked into the region bounded by the graph. Y equals 1, x equals 1. So I'm probably either in here or in there, but we gotta look at the picture. So I'm gonna plug in the numbers that they gave me to help me out. If I plug in 0, I get 1. If I plug in 1, I get 2, no, 3. Plug in 2 is gonna be pretty big, so I'm not gonna do that. But let's graph it to get an idea, right? Okay, so it's a cubic function, so we should know kind of what that looks like. Yeah, so we expected. We're intersecting, just like we said, at 0, 1. So we have a point right here. And at 1, we hit, like we said, 3, right? Yeah, it's right there. 1, 3. So here. Then after that, it kind of shoots off. 2 is way up there somewhere. Who cares? So I'm going to have this kind of shape. Okay. All right. So there's my shape. So I need to decide. So I'm in here, by the way, if it's not clear. This is the section I care about. X equals 1, right? Y equals 1. And this is, of course, the rotational line. So I'm going to rotate this little triangle looking thing around here. We should cause a gap, right? Now, how do you want to slice this? That's the question, right? If I slice up and down, I can use dx, and I can just use this equation. I don't have to solve for anything, which might be easier. But if I go this way, this is how you decide, right? This is how you set it up. I'm slicing up and down because it's going to hit the top part and the bottom part just one time. So this is dx. So the rule says that if the slice is parallel to the axis of rotation, then I should use shell. So if I choose to slice this way, then that means I must do shell. If I want to do disc or washer, I'd have to slice this way, horizontal, which would then make everything dy. So I'd have to solve for y. So this decision to slice this way tells me to do dx, and then you look at the rotation, which tells me shell. So shell method, right? And it's going to be, since it's dx, it's going to be from 0 to 1, right? Rectangles go this way. 0 to 1. So now the P or rho, whatever you want to call it, goes there. The height of the function is going to be the top of the slice, the top part. That's going to be the cubic function. So this is x cubed plus x plus 1 minus the bottom function. So now we have a bottom part, right? It's no longer 0. dx, right? So there is my h.
So the 1 comes from the x minus 1, or?
Yeah, so it's going to be the top minus the bottom. So the minus 1 is this equation, y equal 1. So I'm subtracting the bottom part. You see that? Because I'm not on the axis. So I'm up here. So it's always top minus bottom, but most of the time, or sometimes it's 0, so we don't have to worry about it. A lot of the examples we did before, this was 0. But now it's not, because my region is floating above the x-axis, right? See what I mean?
Yeah, I'm understanding now.
Now we go back to the P. So the P is a section from is from a point on the slice all the way to the rotational axis. So from here to here, this right here is P. So the right side is 2 minus the left side, which is some x distance. I don't know what it is. There's no longer just x. So it's your right minus your left, x.
If it's
So
right
this is,
minus left, wouldn't it be? Oh wait, no, never mind. Sorry.
for P, it's a little bit different. So it's some x distance on the slice all the way to the axis rotation. So 2 minus whatever, some x. So that's the hardest part, setting it up, right?
Yeah. So
You have to decide slicing, and then once you've done that, you decide the method. I forgot my 2 pi, right? And then you decide, okay.
2 minus x is because we're going from the 2.
Yeah, because rotation's over here.
Location
2 minus x. So if the rotation was just right there, you'd say, oh, it's just some x distance. Who cares?
Okay.
Like if it was on the y over here somewhere. So it's not.
So if it was negative 2, it would be negative 2 to the x then.
You mean if I was rotating over here, negative 2?
Yeah.
Then it'd be x minus a minus 2.
Okay. All right. I'm understanding now.
Right, so then we just do the easy part now, right? Integrate this stuff. So multiply all this out. That should give me 2x cubed plus 2x plus 2. Actually, that 1 would cancel. And then minus x4 minus x squared dx. So integrate all this stuff from 0 to 1. You would get negative x5 over 5 plus 2/3, actually 2/4, x to the 4 minus 1/3 x cubed plus 2x squared over 2, 0 to 1. So just plug in the numbers and you will get 2 pi times -1/5 plus 2/4 plus minus. Well, 2/4 is just 1/2, right? So 1/2 minus 1/3 plus 1 minus 0. So that will be some funky number, 2 pi times 29/30, I think. 29,515. Now think about it. I don't think you could use this method because you could not solve for x explicitly, right? You see this? How would you solve for x? It might not be. You might not be able to do it. So you might be forced to do show in this case. I thought you had the option, but I don't think so. All right, let's move on to 7. I think it's 4. Yeah. We'll finish 7 and 4, and then we can do some questions from the homework. 7 and 4, I think, is the easiest section. 7 and 1 to 7 and 4 are the easiest ones in chapter 7. Oh, yeah, use define arc length. All you really have to do is use this formula. So S is equal to the integral from a to b of the square root 1 plus the derivative squared dx. Let me see if I can find a picture of what we're doing right now. Okay. You guys remember you guys remember the distance formula? Way back in the day.
Yeah. It's
So,
this formula is
class numbers.
square root of x squared minus, x to the 2 minus x to 1 all squared plus y2 minus y1 squared.
Yeah, that's right. So the arc length, this one I just wrote down, is basically derived from the original. So basically, if you take an infinite number of arc lengths and you take the limit of it, you will find this integral. Because the distance formula worked with the distance between 2 points, right? But those 2 points were connected by a line. So we're dealing with curves and higher level functions. So you can't just use the square root of whatever. It's not going to work, right? It's your curves. So the theory behind this formula I'm about to show you is this here. So if you have some curve, let's say you have a point 0 and point 1, so you find this distance, and then you find that distance, and find the next one. If you find them and you make them infinitely close, eventually you'll find a sum of distances, which will give you the total arc length. So basically, right here, they're summing each difference in points. So if you find an infinite sum, which we already know, right? That's an integral, right?
Yeah.
So doing all the proof here in theory, eventually you end up with this formula. So this formula will find you the total sum of distance across the curve. In other words, the arc length. That's what this formula does. So they give you a function and say, all right, what's the arc length across the function? And you're like, all right, integrate it from A to B, and you'll find the sum of the arc lengths between A and B. Kind of neat, right? So let's pick a question and try it out. Here we go. All right, so find the arc length of the graph of y equals x cubed over 6 plus 1 over 2x between 1/2 and 2. So let's find out what the heck that looks like, right? Okay. Delete this guy. So this funky function here, x cubed 6 plus 1 2x, right? Okay. So they want to know from 1/2. So here's 1. 1/2 is right about here. So the curve, the arc length sum from here, 0.5, all the way to 2. So you're going to take an infinite number of points between here to here, find the distance between all the infinite points, and you'll find the sum total of arc length. That's what we're doing. Does that idea make sense as to what the heck we're doing right now before we start?
Yeah, I understand it.
Okay, so because the work is easy, I just want to make sure the theory makes sense. So all we got to do is plug it in here and we're good, and do algebra and then integrate. But we need the derivative, right? So what is the derivative of this function? You guys are all derivative pros, right?
Is that a comma in between 1 over 2x?
Yeah, this is
And
the where we're
okay,
finding
that's
the
the
distance.
okay, cool.
X cubed over 6 plus 1/2 2x, whatever 2x.
Wouldn't the first term be x to the power 4 over 4 times 6, which would be
Derivative.
oh
Derivative.
You know, X squared.
oops. It's 2x squared then, no? Or 3x squared over 6.
3x squared over 6. Okay. And the next one?
That's 1 over x. That's 1/2 x or 1 over x.
1 over 2x.
1 over 2
Alright.
x.
That better.
Wouldn't it just be negative 1/2?
That would be the same as if this
1 over
helps you.
2.
It'd be this.
Yeah, so negative 1/2, would it not be?
They would be negative 1/2 x to what power?
Negative.
Oh, negative 2.
Negative 2. Yeah. Okay. So there you go. We still remember our derivatives, right? No big deal.
That class was hazy.
What's that?
The class was hazy. I didn't do face-to-face, so it was kind of a pain.
No, I get you. Well, we're going to be doing derivatives for a while, I'm sure. So it'll stick eventually if it hasn't already.
Yes, sir.
All right, so we have the derivative, we have the formula, and we know where we're integrating, right? So the arc length is equal to 1/2 to 2, right? Square root of 1 plus the derivative squared. So x squared over 2 minus 1/2 x negative 2 squared. So the hard part is now is going to be integrating this. Right now it looks super funky, right? So we might want to try to rewrite this first. This derivative can be rewritten as x squared over 2 minus 1 over 2x squared, correct?
Yes, sir.
And we combine that into one fraction, so that would be x4 minus 1 over 2x squared. You guys agree with that?
I'm assuming you just put the 3 in front of the integral.
The 3? No, the 3 cancels
Yep.
with the 6.
Oh, I didn't even see that.
Yeah, so we get to there. And then combining these common denominator, right? It's going to be this. Introduce x squared, which will get me here.
Got it.
So we may need to do some algebra before we plug it in. That way it doesn't look so disturbing. That looks ugly. We got the dx there. 1 plus, so x4 minus 1 over 2x squared, everything squared. Now it's a little easier to square, right? It's not as disturbing. So that will be, trying to do a bunch of algebra, right? One plus, square the bottom, that'll be easy. 4x4, right? The top will be x8 minus 2x4.
Can you move the page up a bit?
Yeah. Can you guys read that?
Thank you.
Small?
Yes, sir.
Okay. Dx. So then combine the 1 and this, and see if we can do some factorization. I'm going to not write the bounds for a while because it doesn't matter. So the least common denominator is 4x4, so it changes to 4x4. Let me know if me skipping the algebra steps bothers you, or if you don't see how it happens. You have to see how we got from here to here.
No, I got
Yes, sir.
So the denominator is 4x4, so multiply 1 over 1, right, by x4, x4. So then we can combine the two fractions. And once you do that, we need to factor and see if we can cancel the root. So once the root's gone, integration will be easy, right? But right now, the integration is still too difficult. So we'll get to square root of x8 minus, essentially plus 2x4 plus 1 over 4x4.
So when did it become positive? 2x to the power 4?
You have 4 minus 2.
Ooh.
2, right?
Got it.
Okay. So at this point, we have to do factoring. So we're going to get this can be factored into x4 plus 1 squared over 4, actually 2, x2 squared. You see how this is a perfect square on top? So then it will cancel, leaving you with x4 plus 1 over 2x squared. At that point, you just integrate and you're done, right? But do you see how we factor?
the 2x4 and the 4x4, right?
Yeah, so see if I can do it somewhere else. Space on this page. Just real quick. This is a perfect square here. x8 plus 2x4 plus 1. So remember how we said if this is squared and that's squared, you can do a perfect square using your formula, which is, let me show you real quick, in case it's been a while. Perfect square. Yeah, these here. Let me share my screen with you. So this is the formula. A squared plus 2ab equals b squared. So as long as the first one is a squared term and the last one is a squared term, most likely you can apply the formula, but you should always check there's 2ab there. So looking at this guy here, you see how it's something squared, 9x squared, and then a 4y squared. So it can be factored into this. So we're using perfect square trinomial factorization back from either, if you probably first saw it in either developmental or maybe freshman year in high school, one of those. I'm sure it's been a while for all of us, but somewhere around there. So the idea is to rewrite this. Okay, so you forgot. This is x4 squared plus 2x4 plus 1 squared. So this is the formula, right? And then 2ab is right there. 2 times a times b is in the middle term. So that's why I knew right away by looking at it I can factor the top here into this. And I want to make squares in here because I want to cancel the root. So the top squared, bottom squared canceled everything. Does that make sense? I want to make you a note here. Factor with perfect square formula. And it's still 1/2 to 2. And then you'll get your approximate area or arc length. Do you have any questions on this example? I'm not going to worry about the integration at this point. So whenever you do an arc length, the goal is to try to do some sort of algebra thing to make the inside squared, get rid of the root radical, and then integrate. Another thing you could do, depending on what's going on, would be use substitution. But most of the time, you have to just do algebra. Okay. I think the area is, sorry, arc length could be 33/16. I'll let you integrate that yourself later. Okay. All right, let's go on and move on to the surface area. Okay. The surface area will be very similar. You just tack on an extra piece. So the formula would be S, S equal to 2 pi times the integral from A to B of R of X times the root 1 plus F prime of X dx. So R of X is the distance. Sorry, I got distracted. Between the function f of x, or let's call it f, between f and horizontal axis. Of revolution, sorry. And if you have a y version, it'll be similarly.
Professor,
Mm-hmm.
What of x? Is this f of x is the distance? Is this f of x the first of the line?
So this is R of x is here, and this is just f.
The first one is what? Y of x?
This one right here is R of x.
R, small letter uppercase. Okay.
Yeah, I wrote it kind of big, I guess. There you go. R of x.
Thank you.
So r of x is the distance between f and the axis of revolution. So we're basically extending the arc length and spinning it around to find the surface area. Does that make sense? Because if you create a solid with the arc length, you're basically creating a surface. So if you spin it and find the area and spin that area, you'll find surface area. Okay. Find the surface. Find the surface area formed by revolving the graph of f of x equal to x cubed on the interval 0 to 1 about the x-axis. I'm rotating on the x. Okay. Okay. So let's graph that because right now it's like the hell's going on, right? Okay, so let's put 1 right there. We're spinning this way. We'll put 1 right here, I guess. Okay. The x cubed, we know, has 2 points here. And it does this whole thing. Keeps going, but it's 0 to 1, so I only care about this section. And that's the short picture. I used to have a friend that did homework together during Cal 3. And he would draw all the 3D graphs and cut out sections out of it. I was like, Jesus, man, that's awesome. I can really draw 2D graphs. All right, something like this. I think my pen's running out. Yeah, by the way, Cal 3 is just extending Cal 1 and Cal 2 to 3 dimensions. And then n dimensions, I guess, would be vector Cal. Okay, so there's my graph. The rotation axis is here. So from here to here is my r of x. My y, or f function, as they call it, is the cubic function. So the derivative would be that's right. What do you guys think r of x would be?
Y minus x?
It's going to be, well, what's the top of this section here? It's going to be x cubed minus the rotational axis. we got F, we got F prime, and we got R. So now we'll just do integration and see how it comes out. But since there's an R outside, maybe we can do integration, or sorry, U substitution, instead of doing all that algebra to cancel the radical. So I'm going to put the 2 pi out here. R of x is x cubed, right? Times your square root 1 plus 3x squared squared. So this will become x cubed times 1 plus 9x4 dx. So it looks like we can do this U sub, right? I know that was a long time ago, but we can do this. Let U be the inside of the radical, du will be 36x cubed, right? So,
Render 36 out.
yeah, get rid of it, right? Du over 36 gives us x cubed dx. So there's my du stuff. So my integral will become square root of u du over 36. Right? Bring out the 36 nonsense. Change this to u to 1/2 du, which will give us pi over 18, right? U to the 3/2 over 3/2.
Could you move it up a bit? Thank you.
There you go. Now it's funky fractions, but dividing by 3/2 is the same as multiplying by 2/3, right? That would be 2 pi over 3 times 18. How's that?
2018. 54. 54.
Then half of 54.
27.
I believe that will be 27. Double check everything. Yeah. So then, running out of space, we get pi over 27. Change the u back to x. And then integrate from 0 to 1. So that's basically, I'm going to skip those number steps because you guys can plug in numbers. I believe in you.
7.
About some 3.5-ish, something. I think surface area is a little bit easier because sometimes you have to do U sub, but arc length just forces you to do more algebra. So you might have to complete the square. You may have to use perfect squares. So it all comes back to your old school factoring formulas. Because you want to make a square inside the radical for arc length. Does the surface area and arc length make sense?
Yeah.
It makes sense so far.
Okay. All right, then I think we should stop here and go to those homework questions. You guys cool with that?
Yeah.
What was that? Can you repeat that, please?
We're gonna move on to the homework questions, unless you're unsure, unless you have questions about service area or arc length.
Sounds good to me.
All right. I don't want to do too many of these because it's basically just use the formula and figure out how to integrate over and over again. Okay. All right, so the first one was number 9 on 7.3 that we said. Tomas?
Yeah, it was number 9. Part
C.
C. Part C.
My numbers might be different. What was your y equals to?
It's why this one is okay, real fast. I'll tell you. It's the line of y equals 10,
Oh, okay. Yeah, then I have the same.
and then my y. And then you had your numbers. Y equals 10 over x squared. Y equals 0. X equals 1, and x equals 5. And it said choose, either use the disk or method or the shell method. I did them both.
Okay.
I did it both ways, and I didn't come out right either one.
Gotcha. All right then. Let's give it a shot. See how it goes.
That's part C. It's part C of the question. A and B, I got it. Just part C was the one I was having. I graphed it and everything.
All right, let's see what the heck's going on here. So the functions were, let me write them down real quick. Y equals, so use disk or shell. Find volume. And then they gave you these functions that bound the region.
Y equals 0. X equals 1. X equals 5. And then the line Y equals 10.
Okay. All right then, so let's graph the picture. So it looks like 1 to 5. Yeah, you probably need 1 to 5, but let's graph it on our graph first before we do anything. I don't want to just sketch it. Okay, so y is equal to 10 over x squared, right? Y equals 0, x equals 1, x equals 5. So it looks like I care about this chunk right here. So here's 1, here's 5, x, y, and I have x equals 1, so I have this line there, this line here. Well, I'm not going underneath, so who cares about that? So it looks like I'm doing this whole thing. Let's show you back. This. All right. Okay. So we are integrating. So it looks like a good method would probably be, and we're rotating y equals x equals 10. Y equals 10, right? Is that what you said?
Y equals 10, yeah.
Okay, so let's say 10's out here somewhere. It's not pretty, but you guys see the picture, right? All right.
Yes.
So I'm gonna, if I slice this way, which I think is a good idea, I'm gonna hit both graphs one time. Right, the bottom region and the top is just the curves. Doesn't change to different curves or anything weird. So that would be dx 1 to 5. Then we gotta do if we spin that way. Let me look at that graph. Let's say we're gonna have a hole. So yeah, let me share this again. My picture doesn't do it justice. So here's 10, right? I'm spinning this thing all the way up there over and over again. Right? So then we'll have a gap. We're gonna have a hole for sure. So disk will work and shell will work. So I'm thinking just do disk. Okay. So we do disk. The outer radius would be from here to there would be r of x. Inner radius would be minus the inner radius would be from here to there equal to r of x. So the formula for washer would be the outer radius 10 squared, 10 minus 0 squared.
Did that.
Minus, right? I think there's a minus to get rid of the hole, correct? The formula. Then we do
Yeah, it's a minus.
for little r, 10 minus the function. So 10 minus 10 over x squared. Squared. So that's just the disk. That's the washer formula, right?
Yeah,
Okay.
it's R of x minus 0 R of x.
This is
Where each one
r
square.
of x. This is little r of x. Okay. So then start doing our simplification here. So that will be pi 1 to 5 of 100 minus that will be 100 minus
200 over x
200, yeah.
squared plus 100 over x to the fourth
Yeah, that's right.
dx. Yeah.
Okay, so 100 will be gone. So I'll integrate simply 200 over x squared
Do we use,
minus, what's up?
do you use the minus 200?
Yeah, I skipped 2 steps here, I'm sorry.
Okay, I'm sorry.
So right here, 100 minus 100 is gone, right?
Yeah, I'm tracking that.
And then negative, negative makes it plus.
Okay.
Negative, positive, negative. So that's what we got to here. So now we just integrate and the hard part's done. So this will be, bring it up top, be -2 plus 1 be -1, right?
That'd be 200x -1 plus 100x -3.
And negative over x plus 100 over
-3.
3x cubed from 1 to 5.
Okay.
Yeah.
That's
So
right.
doing all that nonsense, we should get 1904 pi over 15. Once you plug in the numbers. Any steps don't make sense? You see how important graphing it is, right?
Yes, my problem is in the graph on the system online, not the graph on paper.
You said 7-1 number, which one?
Number
Will you?
6, because they are all the same. If I get number 6, I will get all of them.
All right, let's go look at it. 7-1 numbers.
Like if you can share your screen and show me how you solve it, I'll have a should solve it.
Okay. Let's see if it lets me. Can I preview this? Test it out? Maybe this will work. Okay, so we have a parabola and 2 parabolas opening up and down, right?
Yes, that's what I did, but it's still wrong.
Hmm. Okay, well, let me see. Let's try it out. Can you see the graph?
Yes, I can.
All right, so let's give it a shot. Two functions, especially each function. So both parabolas. One is down here. Let's see here. This is sideways. Okay. So then 0, 0 is 1 point. 1, 1 is another point. And that
I
should
did
be
that.
first graph.
And the
Vertical
second one, the vertex is on 2. Like you can put the vertex on 2 and the other a negative 1.
The other one, yeah, has a 32 right here. At 0, 32. If I plug in, it's an easy point.
Use the straight arrow.
If I put 4, no, let's put 3. 3 is 9, no, 5. Let's try 5. So if I plug in 5s, that'd be 25. 32 minus 25, what would that be? 7? So if I plug in 5, I would get 7. If this works. Okay. If I get -5, I would get the same deal. And then you have to fill.
Yeah, I never fail. Maybe this is a problem.
Yeah, it's just to fill it, I think. Right? It's supposed to look like this.
Okay, I didn't feel any of that.
Yeah, to shade the region.
So very quickly, can you explain how you did it, like verbally while you are doing it, like how you plot the first one?
Oh, so I'm just picking points, right? So let's go back to on paper, right? So I'm just saying, okay, you know what? You have one function, x squared. Can you see the paper, or do you want me to minimize this?
Yeah, I'm seeing the paper.
Okay. So I said, okay, let's pick some easy points, right? So well, 0, 0, 1 is 1, negative 1 is 1. So I picked those points, and I figured, you know what? I'm just gonna plot those guys first. So here, here. So that was the idea. Something like this. Who cares? Then I went to the next one. So, okay, well, this next one is 32 minus x squared. So let me pick some easy points because I don't want it to be too big, because then I won't be on there. And, all right, well.
Professor, I'm sorry, it's closed on me. Can you switch back to the paper because the paper now closed?
Okay.
Yes, I can see now.
So on this one, I need to pick some easy points. So I'm like, well, 0 is the vertex, so I'm going to get 32, right?
Right.
Now I'll try to pick something that'll show up on the pictures. I'm like, well, I picked 5 because I wanted to subtract the 32, but you could pick anything because it's all on there. So I just chose 5 for fun. So
Okay.
if I plug in 5, you would get 32 minus 25, which is 7. So all right, well, there's 7. Negative 5 will give me the same thing.
Okay.
So then I went here and said, all right, well, here's 5, here's negative 5, and then I went up to the 7 and plotted my points.
Okay.
And then, of course, the vertex is up here somewhere. So all right, something like this.
Yeah.
So then the function filled the rest for me automatically. Once you pick the vertex and 2 points, or maybe just 1 point,
1 point.
the function will just fill out for you automatically. So start with the vertex first, and then pick a point. So
Okay, thank you
choose
so
whatever
much.
you want.
I got it now, and that's what I was doing. I think the problem is I wasn't feeling the function, so it kept telling me wrong.
Yeah, I think that's probably what it was, because I'm sure you did it right. So
Appreciate your help.
Yeah,
no problem. Yeah, is there any other homework questions you guys are struggling with, or is that it?
yeah, I'm not getting that 1904 or 15 pi. Every time I put all the, I don't see what I'm doing wrong when I'm putting in the information.
Plug in the numbers?
Yeah, when I'm plugging in the numbers, I'm just coming up with totally different.
All right, let's try it out now. Pi. So if I plug in, that'd be negative 200 over 5 plus 100 over 3 times 5 squared cubed, actually. Right?
Correct.
Minus, plug in the 1, that'd be 200
Oh, that's wrong.
plus 100 over 3. Okay. So I'll just use the calculator at this point because they're all nasty numbers.
You get 596, negative 596 over 15 minus 500 negative. We got
Just because I'm getting lazy and tired here.
supposed to be minus.
All right, so that'll be 100 over 3 times 125.
I see what I did wrong.
You see it?
Yeah. I was putting plus instead of minus. I don't know why I was putting the plus. I thought since it was a negative and a negative, it plus. which comes out 1904. I see what I do wrong.
Okay, I mean, as long as what matters is getting here, right? Getting this set up is like most of the points on a test. But once you set it up, it means you understand the method. The next thing is showing, do you know how to integrate? And then the last step is, can you plug in numbers? And that's not worth the most, right? Plugging in numbers is whatever. But the setup and the integration is the majority points.
Yeah, I'm understanding it.
Correct. Excuse me. All right. Let's see.
Yeah, I see where I do.
7-3, number 4. Okay. Let's see a question there.
Okay. Okay. That's what I was making. I was doing the washer method earlier.
1 over x. Use shell method to write the evaluation. It's this one, right? Mohammed, this one right here.
Yeah.
Okay. All right, let's give it a shot. Looks like they gave you the graphs. That's nice of them. Generated by the plane region about the x-axis. Revolving the plane region. If I do shell, let me see. Now we're rotating about the x. On this one, this would be way easier. But since they're forcing us to do shell, it's a little bit harder. Do you want to do it with this, Mohammed, or shell?
I would go to the disk.
We'll do shell then first. All right. So they gave us the picture, so let's just go ahead and draw their picture. Okay, I don't really need the negative signs. Here we go. 1, 2, 3, 4, 5. Okay, and then up here they got 1, 2, 3, 4, 5, 6, 7. So this is 0.35 way up here is what they wrote. And down here is 0.05. All right. This is 0.1, 0.15, 0.2, 0.25, 0.3. And you have a section from here to there. Next one is 0.25 here. Okay. So they're rotating on the x-axis, right? Which means if I use shell, I have to do dy because they're forcing me to slice. Shell implies that I need to slice parallel to the rotational axis. So I'm already going to do dy because of that. So I need to change their function So y is equal to 1 over x is what they gave me. So solve for x, and you would get x is equal to 1 over y. So I'm going to use this one. Okay. So one integral, I have to do two integrals because this graph ends after this point. So from here to here, it's a different function, right? See what I mean? So I have to do two integrals, dy. And since I'm doing shell, there's a 2 pi out here. The integral from 0.25 all the way to 0.35, I will be looking at, let's see here. I need my p and my h dy. Okay, so from a point on the slice all the way down will be some y distance. So this is y. Let's make it this. Hold on. Yeah, I don't think it should be just one. Sorry, just double checking here. Vy. Now the slice would be the right function minus the left function. It should be 1 over y minus 3. So that's the first integral here. Now from here to here, I'm going to be using the integral from 0 to, what number is that? 0.25, right? Yeah. That would simply be, again, some y distance times the right function minus the left function. You see how shell is a little bit harder for this one, but it can still work. So now let's make it pretty, because right now it's all screwed up. 0.25 to 0.35. That would be, multiply that out, that'd be 1 minus 3y dy plus 2 pi times 0 to 0.25, which will be 4 minus 3 is 1, so that's really just y dy. So then integrate this, and we would get, we'll put 2 pi way out here, giant brackets. Integrate this guy, we would get y minus 3/2 y squared from 0.25 to 0.35 plus y squared over 2 from 0 to 0.25. And then at the end, multiply everything by 2 pi. And yeah, that should work. Go ahead and plug it all in, I guess. This would be 0.35 minus 3/2 times 0.35 minus plug in 0.25, we get 0.25 minus 3/2 times 0.25. Let's forget the square over there. I'm gonna go ahead and add it over here just to try to be neat. Let's do this guy. That would be 0.25 squared over 2 minus 0. And that should give you 1/12 pi, I think, or something. I think it's calculator time because they give us a bunch of decimals. Okay, so 0.35. Square. Double check everything. One moment. I think I've punched in some stuff wrong. This is squared. Squared. Yeah. Oh, that's good. It was 0.25 to 0.35, right? Sorry, hold on a second. Well, that's not very nice. Check this out. It's not 3.5. You see it? It's below 3.5. What is that? 1, 2, 3, 4. 5. So it looks like 4. 4-ish. Yeah, that's just, yeah, I see why you have problems with this. This question's stupid. So the setup, all the setup is good, but the bounds are very unclear. Does this part make sense, Mohammed? Okay, yeah.
Yeah,
Did you guys have the same numbers or is it different?
I I came out with 34.
Did it work?
And I tell you, I used 34, but and it worked that way. But I just guessed off that one.
Yeah, it looks like 34. But you know what? If you guys aren't, if it's not coming out, did anyone else have problems with that? Did you guys get it wrong, or I'm wondering if it's just a screwed up question.
I'm good.
Mohammed, if you want, I can give you credit for that question. It's not a big deal, but this is how you do it. It's just the bounds I'm not sure of. I don't trust the graph. It's not a good graph. Just email me, Mohammed, to give you credit for 7.
I could email you my work and everything and show you how I did it.
No, I mean it's not that's not the issue. It's just because the graph sucks. I don't think that's fair to you guys. It's so hard to tell. But anyway,
Yeah,
because
it's very-
on the way they did it, they used 3-3, and then it looks like 3-4. I'm like, you know what? Which one is it? So screw this question. I'll just go ahead and give everybody credit for that. This is number
Thank you.
3. Number 4, right? That was.
Is there any news about the last exam, the result of the last exam after you checked the paper? and everything?
No, I'm a little behind. I'm very sorry about that.
No problem. I just don't want to miss anything. Like if you
No,
put it,
I haven't started. I've been moving all week, so I'm behind on everything. But I will try to get that done as soon as possible. My goal is maybe I could do it over the weekend. I'll try to have it done by Tuesday the latest, but I'm gonna try to do it this weekend instead because I need to catch up on everything.